Hey everybody, welcome to Chapter 2 on Basic Concepts in Statistics. Today we're going to be talking about measurement. What is measurement? What are the different kinds of measurement and data? How do we look at data as psychologists? And we're going to be also talking about some mathematical notation, which is a little tedious, but hey, hang in there. It's very important. And make sure we do a little bit of review so we're all on a good footing. All right, let's get started. Before that, let's start with some review. So, the average IQ of people in the US is 100. This is an example of a blank. The answer here is B, parameter. So remember that whenever we're talking about an entire population, and we are measuring something in the entire population, which is pretty uncommon. We don't usually get an entire population's worth of data, but when we do, those things are called parameters. Statistics are for numbers that relate to our sample. So chapter 2 is all about measurement, different kinds of measurement, different kinds of data. What does it mean to measure something? Psychology is a little bit different from other fields because like in engineering or something, or if you're trying to build a building, you can actually pull out a tape measure and measure something's length. It's something you can see. In psychology, oftentimes we're asking about constructs like happiness or stress or something like that you can't visually see necessarily. So we have to figure out different ways of measuring those things. Sometimes it's we give the participant a survey and they fill it out on like a scale of 1 to 5. Sometimes we can do fMRI studies where we're actually visualizing it in the brain and then we have to find out how to quantify that. So measuring something just means basically trying to apply a number to a variable, or at least collecting data in some way on a variable. For instance, it could be like eye colors, not necessarily a number, right? Like we talked about. But yeah, measuring is just about trying to take some observational thing in the world and put it into a number or a category. So let's measure something. How many cups of coffee have you consumed today? As researchers, when we take people into the lab or we're sending out surveys or we're just trying to collect data in some way, measuring our different variables, what we end up with is a bunch of numbers and data that show up in the form of rows and columns, basically a spreadsheet. So we might end up with something like this. So the columns are going to be your variables and the rows are going to be each individual participant. So you can see the first column is for each participant, the second column is for cups of coffee, right? So those are variables. And in each row, we can see that Erica drank 2 cups of coffee, Paolo drank 0, Lee drank 3, Fuso drank 4 cups of coffee. We could also have measured other things on these same participants, right? So let's say we asked them, how many hours of sleep did you get last night? That would be another column because it's another variable that we're measuring. And we would, title that column hours of sleep or something like that. Now, in psychology, we actually typically don't ask people for their names because of confidentiality, right? So instead, we just take their data and we assign them a participant number. And so participant has sort of become a numerical variable, although we don't run like analyses on it. You wouldn't do like, well, what's the mean or participant number or something like that. Like that doesn't make any sense. So we're not really interested in participant number as a variable typically, but we really need it to keep track of, the different data points from each participant. Hopefully that makes sense. And one concept we need to think about is operational definitions. So when you're trying to collect data, you're measuring different things, and those are the different variables that you're interested in. So maybe we're trying to measure IQ, or we're measuring performance on a memory task, or something like that. Well, how do we actually define our variables of interest and how do we actually measure them? Because those things will affect the internal validity of the study. And you read about that a little bit in chapter 1, but basically it's like if I want to measure happiness in people, because I'm going to use that as a variable of interest, and I'm going to say, well, people can be happier if they do X, Y, and Z.
well, how do I measure happiness in a way that is valid? Because happiness means a lot of different things to different people. And so it's a really good idea to try to get an idea of, well, if I want to measure this thing, how would I actually do it? And is that a good way of measuring that variable of interest or that behavior of interest? So for an example of this is like a researcher is interested in measuring levels of depression in a particular population. Okay, well, there are a lot of different ways that you could measure depression. Some of them are going to be more valid than others. So in this first example, it's a behavioral measure, which is I, as the researcher, am just going to sit down and observe each participant and note how often they smile in an hour. And so I'm saying my operational definition of depression is that fewer smiles equals more depression. Or maybe I would have a cutoff of like, well, less than 2 smiles an hour equals depression, which is probably not a very good or valid way to measure depression, I would think, because there's a lot of different situational factors involved, and it's just looking at somebody for an hour. This example too is, well, maybe we look at, if I'm the researcher again, I'm trying to observe somebody and rating how lethargic they are, how kind of like fatigued and unmotivated and low energy they are. Well, that's one aspect of depression is lethargy or low energy, but not that doesn't apply to everybody who has depression, right? And so that also might not be a super valid way of doing it, but it would be one way of measuring depression. And the example three is, what if I hand the patient or the participant a survey and they self-report on various measures, whether they have had differences in eating habits lately, differences in sleep schedules, differences in energy, differences in mood. Um, well, that is a pretty valid way to do it because that person knows most about their own experience. So um, again, just trying to think about, if I'm going to measure a variable, how would I do it, and is that a good way to do it?
All right, now we have to talk about some tedious but very important details, right? And you're seeing on the screen for the first time, oh no, there's letters that are representing numbers, and people start to freak out, right? Getting flashbacks to algebra and those kinds of things. So let's take it slow. X represents different variables. Typically, X represents independent variables, the things that are trying to influence your dependent variable or the outcome. The outcome or dependent variable we usually say is Y. All right. N is the number of participants. Usually capital N is actually the number of people in the population. Lowercase n is the number of participants or your sample size. That doesn't change even if we have whatever number of variables. Okay, so we could measure only 2 different variables on 50 people, or we could measure 100 different variables on 50 people, but n would still be 50. I is a little trickier. Okay, I is the ith score, the individual score for the participant of that number. So for example, if you remember back to the coffee example, participant 1, their name was Erica, and they had 2 cups of coffee. So we're talking about X is cups of coffee, and I for Erica is 1 because she was the participant number 1. And we'll look at an example of this in a second. Okay, so X sub I is the number of cups of coffee for participant I. Because remember, X is the variable, the independent variable, cups of coffee, and I refers to each participant. Okay, so for this example, if I want to know, well, what was the number of cups of coffee for I equals 2, that is participant number 2, then you'd go down to participant number 2, and then you'd check, well, how many cups of coffee did they drink? Participant number 2 drank 0 cups of coffee. So X sub 2 equals 0. X sub 1 equals 2. X sub 3 equals 3, right? Hopefully that makes sense. Whenever you see this symbol, this is an uppercase Greek letter sigma, and it means sum. So whatever comes after this to the right of a sigma, you're going to add all of that stuff together. Okay, well, boy, we're getting a little bit more complicated here, all right? Things are starting to look like proper math. So what we see now is that we have sigma, and what we're adding is going to be to the right of that, and that is the scores, x, for each individual participant, each I, all right? Now, what's above and below the sigma, that tells you, well, which participant do you start with and which participant are you ending with? So how many of the scores are you actually adding together for cups of coffee? Underneath the sigma, it says I equals 1. That's your starting place. So underneath the sigma, that's where you're going to start, which participant number you're starting with. So we're starting with the first participant. Above the sigma, that's where you end. So it could be I equals 2, and then you would just add the scores from participant 1 and participant 2. In this case, though, it says n. That means we're starting with participant 1, I equals 1 below, and we're ending with n, which is the last participant, because that's the total number of participants. Okay. In this case, we have 4 people in our study, in our sample, so n equals 4. So basically what this is saying, all of this together says, add up all of the cups of coffee, that is, add up all of the independent variable scores for each person from participant number 1 to participant number 4. So if you were to add up the number of cups of coffee from participant 1 to participant 4, how many would you get? Well, you just add them up, right? 2 plus 0 plus 3 plus 4, that's 9. So this entire, not really equation, but this entire mathematical term equals 9. And just as another example, like I mentioned before, what's below the sigma is where you start, what's above the sigma is where you end. So this mathematical term is saying add up the scores for cups of coffee from participant number 2 to participant number 3. So you would just add up, you look at the row for participant number 2, they've drank 0 cups of coffee. Participant number 3 drank 3 cups of coffee. So 0 plus 3 is 3. Now, typically in psychology, we aren't really interested in adding only the measurements of specific participants together. We're going to add them all together. We want to find, the sum of all participants' cups of coffee, or we want to find the mean of all participants' cups of coffee, or those kinds of things. We don't typically just add 1 or 2 or even 20 or 40 of them. We want all the participants, right? So that's why all of this stuff here, the sigma xi, and below the sigma is I equals 1, at the top is n, so that means you take everyone in the entire sample's cups of coffee and you add them together. We just do away with that I and n at the top because we're talking about everybody in the sample typically, and so it's often written as just simply sigma x. So that's probably what you're going to see throughout most of the course. Those are going to be basically identical for our purposes. Here's another symbol you're going to see all the time, which is x bar. You see that little line above the x? That's called x bar. X bar is defined as the mean of x. So in our sample, this is talking about the mean cups of coffee between all of the people in the sample. So remember that the mean is simply the addition, the sum of all the scores for a particular variable divided by the number of those scores, or the number of participants that give you those scores. So what is the mean cups of coffee for our sample. It's going to be 2 plus 0 plus 3 plus 4, which is 9, divided by 4, because there are 4 participants, right? Well, that's not a very nice number. What's 9 divided by 4? That's going to be 2.25. That's the mean of our sample, mean cups of coffee drank by each of the participants. All right, and I know you all know this since like 6th grade, right? But order of operations is key when we're doing statistics, because the sum of x squared versus the sum of x squared is going to be very different depending on where you have parentheses. So remember, okay, you do whatever's inside the parentheses first, then the exponents, then you can worry about multiplication and division, and finally addition and subtraction. I'm just going to show you how different these things can be. So if I wanted to calculate the sum of x squared and there aren't any parentheses, what you start with is the exponent. So what you would do in this case is you would square each individual cups of coffee for each participant. So 2 squared would be 4, 0 squared is 0, 3 squared is 9, 4 squared is 16. All right, so you've got all those cups of coffee squared, and then you look to the left, oh, there's that big sigma there. I got to add up all those things. All right, so it would be 4 plus 9 plus 16. That's 29. But what if it looked like this, where the sum of x is actually inside the parentheses, and then we're squaring afterwards? Okay, so we parentheses first. So what this is saying is first you're going to add up all the x values. 2 plus 0 plus 3 plus 4, that's 9. Then you worry about exponents because of, please excuse my dear Aunt Sally, parentheses exponents. So 9 squared is going to be 81. So you can see how different these numbers are depending on which order of operations you do. And I would highly, 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 highly recommend you double check that every time you do some kind of statistical calculation. All right.
Okay, and an important note, because this could change if you're correct or incorrect on a homework assignment. In this course, we round every number to 2 decimal points. So for example, if you get 3.44987, you are rounding to 2 decimal points. We are always rounding to the hundredths place, so that would be 3.45. That's for things like means and standard deviations and all that good stuff. T-values, T-scores, Z-scores, etc. 2 decimal points. And if you get a whole number like 3 for something, you don't necessarily have to put 3.00, but you can if you'd like. Okay, the exception to that are specifically for p-values, probability values. You don't include the 0 in front of p-values, and they're always rounded to the 3rd decimal place. Okay, so like a p-value would be p equals 0.154. That is the correct notation for a p-value. This is all from the American Psychological Association, the APA, and so it is standardized. And if you ever want to get published, this is also how you want to do it.
Okay, I know this was your first sort of taste of math and statistics, really. So I appreciate you hanging in there, and I hope you have a great rest of the day. I'll see you in the next one.